All right, so once again, good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 50 should come up as soon as you log in. Today, like I mentioned earlier, we're probably wrapping up, today and tomorrow, wrapping up the measures of variation so that we can move on to our last measure, which is measures of position. Let's go. So, warm-up 50 should come up. It says compute the measure of central tendency and sketch a box plot. And it gives you a scenario. So copy that and go. Give you some time. All right. Let's get this on the road. It says compute the measure of central tendency. So, first of all, what are they? Anthony E. Go. Mean, median, mode. Or in other words, the mu, Q2, and mode. All right. So, what'd you get for the mean? AJ. 75 point what? 0.62, hands if you got that. Looks about right. How about our Q2? What'd you get for Q2? Ricardo. 60. 60, hands if you got that. Okay. Let me rewrite this. This is 0. 60. 75, 85, yes. Oh, let it go, let it go. 85, 90, 95, and then 100, 100. All right, so Q2 is what, Ricardo? You passed it to AJ, but AJ already helped us out, so let's pass it to Jacob. All right, Jacob, what's Q2? Or the median? $87.5. Hands if you got that. Looks about right. And our mode. What's our mode? Alyssa. 100. All right. Box plot. Q1. Alyssa, pass him one. Meet us. Q1, 67.5. Looks about right. We got Q2 at 87.5, and we need Q3. Pass on one, Mitos. 97.5. Yeah, by now we're experts at this. Maximum 100, minimum 0. Hands if you got something like that. All right, good. Send that in, please. Copy the agenda. Warm-up number 50, measures of variation. Tonight's home play, only 4 problems. Only. Let's go. Oh, yeah, we got this. Especially after a long weekend, you guys are ready to go. Your brain needs, like, big-time stimulus. Oh, yes. Too much, screen time. Let's go. All right. I send you the agenda to your screen. Tonight's home play, 4 problems. problems. Wait. Oh yeah, there's the code right here. 3WVCV. 3WBCV. That'll give you access to the 4 problems. All right. 3WBCV. All right, get a Cornell note going, please. Today's going to go pretty quick, hopefully. It's very basic and it goes well. I like this theorem that we're going to cover today. All right, our objective for today, I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. Like I mentioned earlier, we're in the middle of measures of variation. We should be done between today and tomorrow. We just need some extra practice tomorrow. But other than that, we're moving on. So, with that said, by now we know what measures of variation are. Is that correct? Yes, thank you. All right. Let me send you the screen. Type it on the screen, a definition in your own words. Measures of variation. No notes, all you. By now, measures of variation, you should know what they are. Thank you, sir. Measures of variation. Hurry up, hurry up, hurry up. Type it up. Ten, 9, 8, 7, 6, 3, 2, 1. Here's one from your colleagues. It says, shows how data varies when it's spread out on a graph. Okay, not bad, not bad. Hands if you agree with that? Yes? All right. And we got the notes on that. Let's go to the next one. Fill in the spaces in there, please. Data measures. By now you should know the ones we've covered, the ones we're about to finish, and where we're headed. Got about a minute. Once again, we have 18 formulas already. We're adding to that today. Let's go. You're like, cute, just bring on Friday, bring the pop party on formulas. Let's go. Woo! Woo-wee. Oh, yeah, we got this. All right, we good? Everybody up to date with the names and all that? All set up? All right. So, with that said, let me pause the music really quick because I want to make sure we understand this next portion. All right? So, I'm going to move the screen because I don't want you distracted. You can finish that later. Here we go. Writing utensils down, look up to the screen. So I'm revisiting our normal distribution curve. We already did an intro about this some time back. We use it and you know how to graph it. And we usually stay within the norm. Remind your neighbor what's the norm for that normal distribution. What is the norm? Talk it over to your neighbor. What is the norm? All right. What is the norm between what and what? Let's go here with Martin. What is the norm between what and what? Okay. All right, share with your neighbor once more between what and what is the norm, and then Martin's going to enlighten us between what and what. Yeah. Yeah. That's correct. No, put them behind him. Here. All right. So, Martin, between what and what? What? Help him out, Rianne. The norm? You don't know what the norm? What? Wow. Matthew, the norm. Negative and positive, yes. Negative standard deviation, 1 standard deviation, and positive 1 standard. Really? We've been doing this on warm-ups all day, every day. Ah. So, that's the norm. Now, if I was to ask you how much percent that is, maybe you would have forgotten. But by now you should know that the norm is from first deviation to first deviation, up and down. Now, according to the normal curve, we're at 68.26%. That's what the normal standard deviation is. However, here came about, so look up, this mathematician, writing utensils down, look up to the screen, a Russian mathematician born in 1821. His last name is Chebyshev, and he's considered one of the founding fathers of Russian mathematics, particularly in statistics and probability. And he said, I like this curve thingy, I get it, he's all, but I want to make my own. So, this is what he said. He said that instead of having just a regular bell curve as a normal distribution, he said it begins the same and it ends the same. However, what happens in between doesn't matter the shape. Let me repeat that again. A normal distribution looks like a what? A bell curve, right? Chebyshev says that it doesn't have to be a bell curve. As long as it has a beginning the same and an ending the same, in between you can make it whatever you want. So me, check this out. Well, as a matter of fact, before I move on, I want you to write Chebyshev distribution on your paper. Leave some lines down. Copy this number line. Here's the beginning of the curve and an ending of the curve. Now, he said that it didn't matter what happened in between as long as you have a beginning and the end. So this is what I'm going to do. Look up. That's mine. You don't have to copy mine. That's mine. Why? Because it doesn't matter what the figure in between is, because as long as you have the beginning and the ending the same. So make up your own. If you want to copy mine, that's fine, I guess. So, and he said the rest is the same. Down the center. Tell your neighbor what we label that. What do we label that? By now you should know. What do we label down the center? Looks like Martin got it. But let's go with JJ. What do we label that? The mean. That is correct. I'm going to label that mu. That is correct. Mu. And of course, we have our first standard deviation up, first standard deviation down. We're going to plus, minus. We have a second standard deviation, plus 2, and negative 2. And I have a third standard deviation, plus 3, and minus 3. Once again, if you notice, the distribution's still working the same. But what did Chebyshev say? He said that as long as it has the beginning and the end, the shape in between doesn't matter. Okay? So far so good? Yes? All right. So what else did Chebyshev differ? He said, here goes. Look up. Right underneath his name, I want you to write the theorem. Here goes the theorem. He said, the theorem goes as follows. 1 minus 1 over k squared. Bless you. 1 minus 1 over k squared. Comma, where k has to be greater than 1. Okay? But let's figure out what k is. So put such that k is the number of standard deviation. So let's analyze what he's saying. Okay, he's saying that, check this out, that according to his theorem, 1 minus 1 over k squared, k has to be greater than 1. What is k? The number of standard deviations. So let's look at the standard deviations. We have 1, 2, 3 standard deviations. Could it be 1 standard deviation? Why not? Because it says here what? K is greater than 1. So it cannot be 1. So I want you to, with red, put the wiggles on this, because we're not going to use the first standard deviation. We're going to use from the second one and over. Over there? So that means that his normal distribution, instead of being like ours, look up, instead of being on the first standard deviation, since he can't use the first one, his normal distribution is from where? From the second to the second. That is correct. That's his normal or norm distribution, from the second to the second. Now, how much percent is that? Well, let me show you. With this theorem, you can compute the percent. So here we go. So I'm going to use the theorem. I want to know how much this is. So I'm going to use 1 minus 1 over k squared. However, it says here that k corresponds to the standard deviation. So which standard deviation are we on right now? According to him, what is the norm? 2. So I'm going to write 2 squared. All right, so what is this, Mr. Q? Well, let's see. 1 minus 1 over, what is 2 squared? 4. So what is 1 minus 1/4? 3/4. How much is that in decimal form? 0.75. And how much is that in percent? 75% is his norm. That's how he figured out that that's the norm that he's going to use. You're like, okay, do that again, Mr. Q. Here, let me show you again. Here goes the theorem again. The theorem states that 1 minus 1 over k squared. Since k cannot be 1, it says here greater than 1, so I'm not going to use 1. I'm going to use the next one up, which is what? 2. So I substitute that for k, so that gives me 2 squared, so that's 1/4. 1 minus 1/4 is 3/4. 3/4 in decimal form is 0.75. And how much is that in percent? 75%. Okay. So now look at our normal curve. Look up. Our normal curve has the norm at 68.26%. That's at first standard deviation. What's the second standard deviation percent for the normal curve? It's at what? 95.44. Well, let's figure out what would be the next one up. The next one up is how many standard deviations, guys? For Chebyshev, it will be what? 3. All right, so let's use that theorem again. I want you to write 1 minus 1 over, tell you never what you're going to write on the denominator for the third standard deviation. What do we write for the third standard deviation? I'm going to pass that to Jacob. I think he's ready to go. What do I write for the third standard deviation on the denominator? 3 to the second power. That is correct. So this becomes 1 minus 1 over 3 to the second power is 9. So calculators calculate. 1 minus 1/9 is 8/9. How much is 8/9 in decimal form? .888888. So let's round it to 889. 889. Question, what is that in percentage? What is this in percentage? Yeah, 88.9%. So for Chebyshev, once again, his theorem states that when we use the theorem, we are able to get our percentages between standard deviations. However, his norm is not 68.26. His norm is what? 75. And the second one up, or the next one up, is 88.9. So, check this out. Let me just double check to make sure we got it. Look up, please. Writing utensils down. So, if I was Chebyshev, pay attention, look up, and I said, I want you to tell me what standard deviation am I on, because I'm Chebyshev, yes? if I'm talking about 88.9%. Tell your neighbor, what standard deviation am I on according to Chebyshev? Talk it over to your neighbor, please. What standard deviation am I on? All right, let's see. Looks like Martin's got it, but let's go with, let's go with Darian. What standard deviation are we on according to Chebyshev? That is correct. K is 3. Hands if you agree with that. That is correct. One more. Let's say he didn't want that one. He wanted to be at 75%. Tell your neighbor, what standard deviation are we on according to Chebyshev? Everyone. 2. So K is 2. We get that, right? All right. So with that said, go to the end of your notebook, please, and copy that theorem, please, in your formulas, because we're going to be using that. Label it Chebyshev's theorem. I'll give you some time. Copy and go. All right. So with that said, back to our notes. Copy. Oh, and this is what it should look like by now, yes? So we have now 19 formulas, yes? Let's go, Julius. I know. We're not even halfway there. Let's go. Example number 3, Q. Copy that on your notes, please. And it reads, Mr. Q's statistics formula pop parte had a mean score of 85 and a standard deviation of 4.5. Copy that onto your notes, please. Copy the problem actually. Yes, actually. Identify the range of grades between which at least 75% of students scored. So copy the problem really quick. I'll give you a minute. Go. I'm going to pause the music in the back just to make sure we got this. Here it goes. I'm going to read it one more time. Example Q. Mr. Q's statistics formula pop parte had a mean score of 85 with a standard deviation of 4.5. Identify the range of grades between which at least 75% of students scored. So, when you get to these problems here, when they're asking for a certain range of whatever that may be, that number or those numbers, I want you to write 4 things right away on the side. Over here, I want you to write mu, standard deviation, percent, and RK. All right. So, what information do we know for those 4 from what they gave us on the problem? Let's read it. It says, Mr. Q's statistic formula pop party had a mean score of 85. So what's our mu, everyone? 85. Okay, we got that. What's our standard deviation? 4.5. What percentages are they talking about? 75. So that means, what is our K? Tell your neighbor, what is our K according to Chebyshev for that 75? Everyone, what is our K? 2. Yes, 2. All right. So we start with that. So with that said, check this out. If we were to draw a curve, so draw your number line first. I'm not going to draw the curve just so that it keeps us focused on the numbers first. All right, but what is the first data that we write down in our curve if we were to get a curve started? What is it? Yeah, the mean. So write mu. In this case, it's what? 85. All right, so according to this data, we are in the second standard deviation, yes? So we go 1 standard deviation, 2 standard deviations. I want you to write 2 standard deviations, up and down. Okay? And once again, we know that. Why, Mr. Q? Why do we know that? Because according to Chebyshev, that's how much percent? 75%. So, What are they asking in regards to that 75%? They say, identify the range of grades for that pop parte. So what was the mean for the pop parte? It was what? 85. So if 75%, which is the norm, fell between the two standard deviations, what numbers are that? Well, we just use the standard deviation, and we go 2 up and 2 down. So here we go. So 85 plus 4.5 is 89.5, but that's only one standard deviation. So if I go another, that leads me to what? 94. Yes, 94. But that's upward. How about downward? 85 minus 4.5 is 80.5, but that's the first standard deviation. Second standard deviation is 76. So for the 75%, what are the ranges of the scores, guys? From what to what? From 76 to what? So let's answer the question. The range of grades is from 76 to 94 for the 75%, or the normal distribution. All right? Oh, 10Q. So let me go through the process one more time, just to make sure we got it. They're asking us for a range of data. They give us a percent. They give us the standard deviation and the mean. What did we need to find? We needed all this data over here. How many data? 4. The mean, standard deviation, percent, and what K we're on. From there, we drew our line, started with our mean. We said we're on K2, so we go 1, 2 up, 1, 2 down. That's our norm, which is 75%. And then we just use our standard deviation to move 2 to the right, 2 to the left, and that gives us our range from 76 to 94. So send me your notes, please. Let me send you that, and then we're going to do one more to make sure we got it. All right, here's the next one, example Super Q, and it reads, Mr. Q's Algebra 2 Transformations Pop Parte had an average score of 80 with a standard deviation of 3.2. Identify the range of grades between which at least 88.89% of the students scored. So, very similar to the one we just did. See if you can do that one by yourself. I'll give you a head start. And you don't have to copy the problem. You can start from the 4 values that you need. Let me send that to your screen. Go. Like Ricardo's almost done. Very good, Ricardo. I see you. Type it over your neighbor to see what they got, please. All right. Here we go. For the sake of time, our mean is what? 80. That is correct. 80. And our standard deviation, 3.2. Our percent is what? 88.89. And what K are we on according to Chebyshev? Everyone? 3. That is correct. 88.89 is 3. All right. So, with that said, this is our mu. And we are on third standard deviation. So 1, 2, 3. Third standard deviation. 1, 2, 3. And we are at what percent? 88.89%. All right. Help me out, Donna. If we go upward by 3.2, what is my next value? 83.2. And the next one? And the next one? How about the other way? Pass someone? Vanessa. Uh-huh. And the last one? 70.4. Hands, have you got that so far? All right, so tell your neighbor the statement that you're going to write for the answer on that one. What is the statement? Okay. Oh, no. All right, conclusion. JJ, what? No, not you, Jay. Nick. Yeah. Conclusion. From 70.4 to 89.6. Hands, if you agree with that? Yeah, the average score for the 88.89% between those two. Send that in, please. Let's move on to the last example. Here we go. It reads, example 2Q. A survey of local companies found that the mean amount of travel allowance for couriers was 0.25 per mile. Couriers being the person that is delivering packages. So, for example, you know how you guys get your FedEx or UPS and all that? They are known as couriers because they carry your packages. They are allotted a 25 cents per mile, so they give them an extra amount of money per mile, and that's a quarter per mile. The standard deviation is 0.02. Use Chebyshev's theorem to find the minimum percent of the data values that will fall between 0.20 and 0.30. You're like, oh, this is a little bit different. Yes, it's a little bit different. However, we can start off with the same data that we need. So write it on your paper, example 2Q. And then we write mu, standard deviation, percent, and K. All right, get our number line going. Oh, get our information. We have the mean being how much? 0.25. What is standard deviation? Standard deviation is 0.02. Do they give us a percent? No. Do they give us a K? No, that's what we need to find. So, draw your number line. Back crooked, so crooked, okay. Start with the mean, which is 0.25. And what are the values that they give us that fall between what numbers? 0.20 all the way to what? 0.30. So I'm going to go over here to 0.30. Right here. 0.30. And over here to 0.20. So we want to find out what this percent is, what that percent is. So, check this out. In order for us to know the percent, first we need to know the K. Is that correct? So check this out. Since we don't know the K, we need to find out what is the distance for each of these. So question, what is the distance from here to here and from here to here? 0.05. So I'm going to write 0.05. Now, since I want to find out where I'm at in regards to standard deviation, what was the standard deviation? Point what? 0.02. So I do this. I take standard deviation, and I'm going to divide this distance by 0.02. And that's going to give me where I'm at in regards to the what? The K. The K. So calculators calculate. 0.05 divided by 0.02 is 2.5. And that is our what? Our K. So I'm going to write it here. 2.5. So, does anybody know a formula on how to get the percentage for Chebyshev? What is it? Close. Let's go to the beginning. The formula that you wrote down on your notes was what? 1 minus 1 over K squared. What is K now? 2.5. That is correct. So, 1 minus 1 over, what is 2.5 times 2.5? 6.25. So, calculators calculate. 1 minus 1 over 6.25. That should give me a decimal. .84. And what is that in percent, everyone? That is 84%. Yeah, you can also do another one. Yeah. So, send that in, please. I'll give you one more for you to do by yourself that is very similar to that one. There it is. So for this one, we would write the minimum percentage of data values fall between 84%. All right, so here goes the setup one more time. We have our mean. We label it. We label the extreme numbers that they give us. Take the distance divided by the standard deviation. That gives us our K. Use our formula, and that gives us a percent. So here goes example 2 super Q. Again, start with the data that they give you. Mu, standard deviation, percent, and K. And mu for this one is the average. The average is what? 12. And what are my extremes? My extremes are 4 all the way to 20. So remind your neighbor how to find K. How do we find K? Using that data. Then Darian's going to enlighten us. How do we find K? All right, Darian. We're given the mean. We're giving these. The distance from here to here and here to here. What's that distance? 8. What do we do to 8? To find K. Divided by what? By 3. That is correct. The standard deviation. That's going to give us our K. What's our K? What is it? 2.67 is our K. Now that we have K, 2.67. Our mean is 12. Standard deviation is 3. We need the percentage. Compute the percentage. Send me your notes. All right. Looks like AJ's got this. 1 minus 1 over 2.67 squared. What's the decimal form of that? 1 minus 1 over 2.67 squared is what? 5 what? Yeah. This one? Divided by the standard deviation. 12 to 20? From, no. But this is from the mean to the... Decimal. What was our decimal? You got it. Yes, how do you say? 0.85. And this is 85%. From 1 to 5, how comfortable are you with Chebyshev? 5 fours, all right? Go ahead and log out, please. Your home plate for tonight is only 4 of these problems, so make sure you get that practice in. I'll stop the video right here. Those of you following on YouTube, make sure you follow and do your practice. Bye. Have a good